Welcome to Lesson 70, Algebra 1 3rd edition, Saxon. Um, Today's lesson is on probability and designated order. You might think when you do something like roll dice or flip a coin that the outcome is random, and to a certain extent it is. However, there are mathematical ways that you can predict certain outcomes. And that's what we're going to talk about in this lesson today. Alright, so probability, the definition of probability is possible choices divided by the total number of options, or number of times the event occurred divided by the number of trials, or finally the number of favorable outcomes to the number of possible outcomes. You can see that as a ratio. On a dice, on a single die, you have 6 sides, and there are 6 numbers, 1 through 6. So let's take a look at some scenarios where we would roll the dice. Well, sorry about that. We're going to toss a coin. And in a coin, you have 2 possible outcomes. And depending on which one you called, you would want either heads or tails. Alright, so let's say that you toss a fair coin 4 times. And the question is, what is the probability, not possibility now, but probability, that the first 2 times it comes up heads and the last 2 times it comes up tails? Now, this is something called a tree that you can sort of use. You see that the first time here you've got 2 outcomes. You've got heads and tails. Well, the second time you've got 4 possible outcomes. On the third you have 8 possible outcomes, and on the fourth toss you have 16 possible outcomes. So 4 times the probability that the first 2 it comes up heads and the last 2 tails. Well, every single time you toss it, it's going to be a 1 in 2 chance. So if you toss it 4 times, you would simply say 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2. 1 over 2 times 1 over 2 is 1/4 times 1/2 is 1/8, and 1/8 times 1/2 equals 1/16, and thus the 16 different outcomes over here. Okay, how about on a spinner? We're going to try to calculate the probability and decide how likely each event is to happen. Alright, on this particular spinner there are 8 possible outcomes. So our fraction is going to be something over 8. Like in a coin, it's 1 over 2, or 2 over 2, or whatever. And in a die, it would be 1 over 6. So, and remember to show the fraction in lowest terms. Alright, so let's say, and I'm sorry I got this off a website, and you're not going to be able to actually do it, but possibly we'll be able to find that at a later date. So this one has 8 possible outcomes, and you would say every time 1 over 8 times 1 over 8 times 1 over 8 to get a particular outcome. Alright, here we have, on this spinner, we only have 4 choices. So our bottom number of our fraction is going to be 4. The spinner shown is spun twice. What's the probability that the spinner stops on 4 and then on 3? Well, the first time we have a 1 in 4 chance that it's going to stop on 4. And the second time, we're also going to have a 1 in 4 chance that it's going to stop on the 3. So we have a 1 in 16 chance. 1 in 16 times this will actually happen. Okay, look at your practice problems. A fair coin is tossed 3 times. What is the probability that it will come up heads all 3 times? All right, well, I found a little tree here with your possible outcomes, but for the sake of our lesson, let's just say a coin only has 2 sides, so 1 out of 2, and we're going to toss it 3 times. So our outcome is going to be 1 in 8. Okay? Alright, here we have a single die, so we know that our fraction is going to be something over 6. It's rolled 3 times, so times something over 6, times something over 6, 1 over 6. So what's the probability that the next roll will produce a number greater than 3? Well, how many chances do we have? Every time we're going to have, in this one we're not actually going to do the 1 over 6 because of what it's asking us to find. In this one, we only have 3 choices that are greater than 3, and that is 3 out of 6. So 3 outcomes out of 6 could be a number greater than 3. We're going to reduce that to 1 over 2. Alright, now you'll see this little chart at the bottom of page 285 in your lesson, and this is going to be really handy. I would advise you to copy this in your notes. I will be looking for it in your notes. Alright, this says 2 dice are rolled. Now, if 2 dice are rolled, you have the possibility of 6 times 6, or 36 different outcomes. So what is the probability that the sum of the numbers rolled is 6? Well, then what we need to do is find out how many 6s there are on this chart. 1, 2, 3, 4, 5. So we have a 5 in 36 chance that the sum is exactly 6. And that's how you're going to use that chart. Very handy to have, by the way. Okay, now this is one we haven't done yet. It says that there are marbles in an urn or a jar, and this particular jar has 6 marbles and 6 pink and 7 blue marbles. Now that is a total of 13 marbles in the jar. So a marble is drawn and dropped back into the urn. Then a second marble is drawn and dropped back into the urn. Both marbles were pink. If another marble is drawn, what is the probability that it will be pink? Well, when I draw, if there are 6 pink and 7 blue marbles in the jar, then every time this is called an independent event. Every time that marble is drawn, I have a 6 in 13 chance of getting a pink marble. Alright, so that's how that works. Okay, here we have a spinner. The bottom number of our fraction of this particular spinner is 4. It's spun 3 times. What is the probability that the spinner stops on 2, then 4, then 3? There's only 1 2 out of the 4, 1 4, and 1 3. So what is the probability? Well, if we've spun it 3 times, we have a 1 in 4 times the 1 in 4 times a 1 in 4. Okay? So we have a 1 times 4 is 16 times 1 in 4. We have a 1 in 64 chance that this will happen this exact way on this spinner. Alright, good job. I'll see you back tomorrow for lesson 71. And don't forget to copy that chart with the possible outcomes of 2 dice being rolled.